Alright, we're going to do the solutions to the cross-section worksheet here, and this is a section that can be a little confusing at first, but once you get the hang of what's going on, it's one of the easier things that we do here. So this one says you have a region that's created by these two functions here, f and g, and it's the base of a solid, and if you were to cut that at the x-axis, you would, and open it up, you'd see a square. So the first thing we're going to do is get a visual. I put those in y1 and y2, and we get this here. We have the what appears to be the cubic graph. Let me see which one that is here. That's the bottom one, so that's important to know. And then the quadratic graph is the one that's on top. So g of x is the top one, and this is the bottom one. All right, and so if we kind of retrace it here a little bit, we've got this going like that and this going like this. All right, and we'd like to know where they intersect. So if I calculate that intersection, we get an intersection at x equals 3. Okay, so our integral that we'll be setting up for this volume in a little bit will be from x equals 0 to x equals 3. Now, what we're trying to visualize again is if I were to cut this at some random x value and open it up, what I would see is a solid, and the side of that solid would be a square. All right, so if I kind of draw the representation of it right here, all right, this side right here is the same as that side right there. So again, it's kind of hard to do a three-dimensional thing, especially when you're not very artistic like I'm not. But this side right here is this side, and the length of that side would be the top function minus the bottom function. So for us, that's g minus f, okay? That's my top minus bottom. And since it's a square, that would be the other side too. So the area of this square would be g minus f squared. Now, because we're talking about volume, we need to think of a third dimension, a width of that. And we want that width to be very, very tiny. And so we give dx, the description for the width of that, something super small, almost 0. And that would give us the volume of one particular square at some random x value. What we're going to do now is add up all the squares from x equals 0 to x equals 3. And that's what this does here. There's no pi involved because we're not spinning it around anything. We're just taking those squares as is. So again, once you understand this concept, this is one of the easiest things we do in this section. So I take the calculator and I go from 0 to 3, y2 minus y1 squared dx, and it ends up with 101.829. All right, so not too bad on that one. Second one also is not too bad either. We have a region that's created by these two functions here, and is the base of solid, and it's similar description. So let's get a visual on that. So if I were to turn those two on, turn the other two off, and we'll probably have to go a little bit further out on this one, but probably not as high. So let's see if that works there. Okay. So here is our region, and we're saying that this is the base again of a solid. And so we want to, if we were to go 5 times the length of the, so what we want to do is consider what this looks like. Got it kind of looking like this, and then it comes down and does that. Okay, so we need this intersection point here, and then we also need a look at something else there. So let's go ahead first and look at, now I'm looking at bounded by like this, but I'm wondering actually if it probably goes like this. My apologies for being confused in the middle of a video here, but I think what I want to do is treat it more like this. It's going to be coming from here, and I want to look at this region there. So that was definitely a little more confusing than it should have been, and that's my apology on that. But this is the region we're going to look at right here. Okay, and if I were to take a cross section from that, all right, and look at it and kind of pull it off here. Again, this side is the same as that side right there. And that's going to be the top minus the bottom. Now again, G is the top and F is the bottom. So we'll have G minus F for that. And then the side, we're told, is 5 times the length of that. So we're going to have 5 times G minus F for that. All right. And now if we were to think about the area of this, it would be 5 times G minus F times G minus F. So 5 times G minus F squared. Dx would give us dimension. That would give us the volume of one particular rectangle coming off the page. We're going to integrate that from 0 to 7 because that's where these intersect. All right, and then and that'll be our total volume then. And so if I were to do that on the calculator, go 0 to 7 and do that there, I end up with 739.833. All right. So again, this is something that can be pretty easy to grab onto once you understand what it is that we're talking about. Don't try to just memorize a pattern, try to really understand it. And if you do, this, like I said, will be one of the easier things we do in this section.